Yeah, so guys, please just notice that I don't really kind of bother you with any more about an announcement when the lecture recordings are ready. So please just double check the lecture site. Normally, I'll try to make sure it's available at least before the next class. I'll try to be sooner sometimes if I can, but if I get a little bit more occupied by other things, at least I'll make sure it's available before the next class. So please double check if I don't remind you. Let me just, some very important thing to announce, because next Tuesday there's no class. Everybody should really recharge. Canada Day, right? We should celebrate, right? Good. So no class next Tuesday. I will be checking my email. If you really got something you want me to ask me, I'll try to respond. That's not a problem. Okay. But Thursday you have your programming test. So this is what I'm thinking. Okay. Of course, you gotta make sure you finish your assignment number 2 as soon as you can. And for project, just don't forget your team.txt file is actually due by the end of tomorrow. So please find your teammates. If you got any trouble finding them, as I said, reach out to me. Okay. And for your programming test, right? So the guide for sure will be released maybe early or mid-afternoon tomorrow. I already got a draft. I just need to double check some detail with Shanru, the TA. I want to make sure everything there is correct. So I'll definitely release the guide and also the practice test to you. Okay, and the practice test actually will give you a very good idea about the actual test, at least the format, right? And then definitely tomorrow. Okay, and the mock-up test has been reserved. So again, the mock-up test. Okay, let me just clarify this. So the mock-up test, number 1, is going to be in person, as I mentioned earlier. It's going to be in Lausanne 1002. Okay, it's in the Lausanne building 1002. It's going to be 5 p.m. on Monday. And then I'm going to run it for until 6:20 p.m. So you can definitely experience about 80 minutes test range. Myself will be there, and also Shanru, the TA, will be there. So we don't mind if you kind of interact with us just about how to do certain things. So Shanru will be there also to walk around to help you guys. So take advantage if you can make it. I do apologize, the time may not work for all of you, but please try your best. That's kind of the best we can do. Otherwise, it would have been nice if we can schedule mock-up test on Tuesday, but it's a holiday, right? Nobody wants to come, seriously. Okay, anyway. But the test I'm gonna use on that mock-up test will be the same practice test. I will make sure I give that to you by the end of tomorrow. And also, I included one section in the guide just to tell you how you can simulate the actual test on the remote lab. So if you don't really want to commute to the campus on Monday, you don't have to. Okay? So let me clarify that. And then it will be the same test as the practice test. All right? So when we reconvene the class next Thursday, July 3rd, I'm going to meet you guys in Lausanne. Oh, yeah, okay, how about this? This one is going to be mentioned in the guide, right? It will tell you exactly where you should go, but I believe it's Lausanne 1002, the same room. Okay, you just go there, and then I'll meet you there for the test. Just make sure you arrive in time. You got exactly 80 minutes for the class. And then the makeup lecture is going to happen right after that. I still need to confirm with you about the location, but we can be slightly flexible. Let's say about 7:15. Maybe after the test, you can take up to half an hour, take a dinner break, take a break, and then come back for the lecture, and we'll do no more than 80 minutes. If sooner, I can finish sooner. Okay, I think that'll be easier. Okay, just throwing to you some recording. I think it'll be better. All right, any questions? All right. Very good, thank you. Let's now do a very quick recap. I think today hopefully we can definitely finish a composite design pattern, and then we can talk at least the good part about visitor pattern. I think the visitor pattern, once we talk about it, it might give you some good inspiration about some basic feature for type checking. I'll give you some hints over there. Of course, a very general hints, not very specific, because what you guys are going to do in the project will be something much more advanced than what we can talk about in the lecture. Okay, recap. So last time, we actually, of course, we went over the project specification. You can refer to the recording. If you got any doubts about the project milestone, etc., of course, for milestone number 1, number 2, before the deadline, I will also give you guys a guide about what exactly you should really submit. So you don't need to worry. For now, just meet with your teammates and start working according to the minimum list I give to you. And then we spoke about just this one single example there about given the context-free grammar, there are two kinds of derivation you can do. You can either do the textual derivation, and there's a distinction between leftmost and rightmost. In this particular case, we only got a single variable as part of it. So the leftmost and the rightmost will just be the same. So once we finish the design patterns lecture, most likely on Thursday, we're going to see a little bit more complicated scenario where you do have to make a choice about which variable to really derive first. We'll get there. But at least understand this example here about applying different production rule. And then another way is to build a parse tree, right? In Antler 4, the tool, you can also visualize the parse tree to some extent. It's really about if the string you have satisfy or is somehow legitimate according to some grammar, you can build a parse tree. Otherwise, you cannot build it. So this is why, for the most part of your projects, once you design the grammar of your own language, if you can pass some input file that has the right format, it's going to build you a tree at the runtime, like what we said in the tutorial. Once you get a tree, all that's left is about doing some semantic processing, about type checking specifically, and also pretty printing as well, because you want to somehow pretty print the type checking result into some HTML, right? So that'll be the fun part you guys can play with. All right, so we definitely revisit the syntactic analysis lecture from next Thursday again. All right, so let's now get to the point. So this is the motivating problem that we're trying to solve in these two design patterns. So composite and visitor, they really usually talk about all together. You usually talk about composite, which is about the tree structure, and then visitor, which is about how you can traverse the tree and do some semantic analysis. We'll do both today, hopefully. Right, we talk about recursive components, which will be some subsystem, which can be arbitrarily big. Just think about in 2011 data structure course, if you have a general tree, the tree can be arbitrarily large and arbitrarily deep as well. Just gonna remember, you got recursive case, like internal nodes, and also you got base cases, like external nodes, like leaves, right? So these are the terminology. I assume you guys are okay from 2011. Okay. And then, so these two pages are just like a very quick recap about what you learned from 2030. So let me just summarize about what you're supposed to know, right? Again, I gave you the links in the very beginning. Let me just emphasize again, I think that might be a nice way for you to plan, also for your written test later, and also for the exam as well. Okay. So if you look at the very first slide right here, so we're going to need the knowledge about inheritance and also genericity. So these are the two things. Right? If you want to catch up with or to brush up your previous understanding, you can refer to the resources, or you can just go back to your 2030. Maybe you didn't take it with me. That's okay. Just review your material. Make sure you understand that. Okay. Okay, so that's about recursive system. And then we're now going to talk about how we can build some Java project or Java model package classes that's going to implement recursive system. So here is going to be the roadmap. I'm going to give you guys 1, 2, and 3 different attempts for this recursive system. And then we're going to briefly, we can briefly discuss, or I can just tell you what the drawbacks is for each one of them. And then we'll see how we can arrive in the ultimate design. And the very valuable lesson for us will be, as we present each design, I'm only going to give you some design diagram. I'm going to explain to you the notation very soon, okay? So you can know how to read this diagram. So this diagram notation here is something we assume also when you write a written test or the exam. Of course, ask me a question if there's any part you're not too sure, but I'll explain that too. So when we talk about each design attempt, number 1, number 2, and also number 3. So these are the 3 approximation of the final design for the recursive system. But none of them is perfect yet. So we're going to see the composite pattern is going to somehow address each of the limitations that we're going to see. Right? Of course, to really understand the limitation, you have to recall static type, dynamic type, polymorphism, dynamic binding. Okay? Let me just do a very quick page just to give you a very quick reminder. Of course, to really see the detail, you will actually have to explore some resources about the 2030 stuff. Okay, let's do some very quick recap. So number 1 is about static type. Since we talk about OOP, Static type is really the declare type of a variable. Declare type of some variable. So let's make it a little bit more abstract or symbolic. If I declare T, which is a class, and then X. Okay, if I declare this, so T over here is a type, and in Java or in any OOP, a type is simply correspond to some known class. So this is some known class. So that means somewhere in your system or in the library, there should be a class called T. And then there might be some stuff inside. What's really important about static type is you can think about later on, let's assume that you already create some new objects and store the address in X, right? Use a new notation. If I say X dot, and then over here, what will be the expected range of methods or attribute you can call? So that one is completely determined by static type. Okay? So this will be the range of expected, or you can say compilable. Static type is really a way for a Java compiler to determine whether or not your method call should compile. And that might be something you want to do as part of your type checking. Right? So in some way, I'm also talking about some rule. The range of expected compilable methods or attributes, if the attribute happen to be, for example, maybe public. Callable on X. For example, let's say here if we got integer X, and also we got, for example, some method void, let's say MT, method T. And some stuff over here. Let's say these are the only two things we declare in class T, let's say. And there's no parent class, etc. Just make it simple. Okay? In that way, the only thing you can pass over here would be X and MT. Right? Anything else. For example, if I want to say X dot maybe M Y. Oh, not a good name. Anyway, let's say MU. Let's say it's a method from another class. But it's not really declared in T, which is static type. So it wouldn't compile. Right? This kind of stuff might be something you more or less know when you answer the test question. But now, since you're going to implement a compiler for this kind of type checking rule, so you got to be very explicit and clear about how to implement them in your compiler. All right, so that's something. That's also a nice exercise for you. Whenever you want to make something precise, the best way to do it is make a compiler for that. All right. Okay, static type and dynamic type. Static type is really about the range of methods or attributes you can call. Dynamic type is dynamic type. It's really about the actual instance being pointed to. The type of actual objects being pointed to. Okay, let's make a very obvious example. Let's say, if I got, for example, objects, right? Object is a class in Java, right? Let's say objects obj. All right, and then I might say obj equals new. Let's say we have a class called maybe C1. And then later on, I might say, oh, let me just talk about dynamic binding at the same time. Okay, and then I might say obj dot method m. Okay, let's say this is okay. This is 1, this is 2, this is 3. Let me write 2 more, and then I will bring you the context, right? Number 3, and number 4, and number 5, okay? So number 4 would be, I got obj is reassigned to new, another class C2, assuming that C2 is defined. And then I'm going to say obj dot m. Again, okay? So there are certain assumptions I'm making here. Let's write them out. There's an inheritance hierarchy over here. So you can say we got the object class underneath it, because we know that by default, every class is a subclass of objects. So let's say we got C1 over here, and also we got C2 over here. Okay, C1 and C2. Okay. And then, why don't I make it a little bit more, so we don't need to get into typecasting. That'll be too complicated. Okay, if you don't mind, let me change that very quickly. C1 and C2. Let's say I just define that to be C. Okay, and then I will put C right here. So 3 classes: C, C1, and C2. Okay, and then let's say we define some method M over here in C. And then we overwrite this method M in C1 with some customized redefinition. And also we redefine, overwrite M as well in C2. So now we got 3 versions. We got version 1, version 2, version 3. But of course, if you want to make it fancier, you can also make C itself abstract class if you want to, right? I wouldn't go there for now. Okay, so now we got C and C1. Based on what we discussed on Tuesday, the left-hand side here has a type C. Can you assign something that's C1 to it? Yes, because assigning C1, that's something more specialized to something that's more general, right? That's kind of the polymorphic intuition we spoke about on Tuesday, okay? That one, you can refer to the recording. And then this one here, does this compile? It does, because OBJ has a static type C. C has the method M, right? That's kind of the compilation you have to do in your compiler, type checking. Similarly, when I have obj.m here, again, obj has a static type C, which never changes. And that one there has M, right? So now, as far as the static type is concerned, we are quite fine. Always C. So let's draw a table here. So we got a table here, and then, so let's say after certain line. So I'm going to have, let's say after line number 1, after line number 2, also after line number 4. Okay, let's talk about these 3 lines first. Okay, and then we want to know about what's the static type of OBJ, and also what is the static type of dynamic type. Beg your pardon. What is the dynamic type of OBJ? Okay, let's talk about these first. You can see after this line over here, OBJ is simply storing null. There's no object it is pointing to. So dynamic type, nothing. So after 1 over here, you can think about OBJ just pointing to just null. Okay, conceptually. And then after 2 over here, OBJ is going to store the address of some C1 objects. So it's going to point to, after 2, going to store some C1 objects over here. All right. After 2, the dynamic type will be C1, because you can see that this is the dynamic type you can keep track of. This is the dynamic type. All right. Similarly, if I go for line number 4 here, I'm going to reassign. Okay, so for that one there, I'm basically creating another new object here of type C2, right? So I got this object over here, C2, okay? And then for OBJ, rather than pointing to here, it's now going to point to here after 3. Oh, beg your pardon, after 4, right here. So after 4, what's the dynamic type? It changes to C2. So you can see the dynamic type can change anytime. And we're going to talk about the consequence of changing them in just one moment. Okay? What about static type? Always the same. All right? The static type here for OBJ, once declared, remains to be C. Always. You can never change the dynamic static type for any variable. All right, so far so good? Okay. And let me just say one more thing over here. Of course, this is just another dynamic type. You don't necessarily have to draw a box like what I do. That's just my habits of keeping track of things. If you have your own tracking system, feel free. That's okay, as long as you have a way to keep track of the dynamic type for your variable. Okay. And then let's now talk about two more lines. So I can talk about dynamic binding. So far we talk about static type, we talk about dynamic type, and dynamic binding. I'll put some definition here. Dynamic binding. Dynamic binding simply tells you the version of the method that's being called corresponds to the dynamic type of the variable. The version of method that's invoked depends on the dynamic type of the variable. Okay, let's now do example right away. And we can use the same example. That's how I set it up. You can now take a look at line number 3 and also line number 5. Right? If you look at line number 3 and line number 5, I got obj.m, obj.m, identical. Are they going to call the same version of m? Not really, right? So according to the definition here, right, after line number 2, we know that dynamic type for obj is C1. So that means this line here is going to call the version of m that corresponds to the dynamic type of obj, which is C1. Okay? So this one over here is going to call the m from C1. Okay? That's the first line. That's the first point you're going to notice. On the other hand, if you look at this one here, according to our table, after line number 4, the dynamic type of obj has become C2. So now we're going to call the version of C2, m. All right? So that one there is going to be call the m from C2, right? So this is really something we have to rely on your knowledge in order to understand composite and also visitor, right? I just want to mention just in one page about the different concepts that will be required to study composite and visitor. If you're feeling completely comfortable, hopefully you understand most of the things today. If not, you may want to catch up with some study. Any question about what I have said so far? Static type, dynamic binding. Okay, if you guys are okay, why don't we move on? Okay, but any part, I'll try to maybe kind of mention about this different term as we go over. Okay. One more thing to mention. You will see some diagram notation in the design diagram. Okay, so typically the red, well, of course, in the actual exam on the paper, you may not see the color, right? So you gotta pay more attention, right? If you see the arrow like this, usually arranged in the vertical way, right? Like an arrow, and with the empty arrowhead right here. So these typically mean inheritance. So we are saying that this drive is a class that extends equipment, okay? And also, for example, here we say cabinet extends composite equipment, okay? That's what we meant. So whenever you see vertical arrows with the empty heads over here, that means inheritance. And if you see abstract over here, that means abstract class. If you see interface over here, of course, it means interface, right? So these are, you can see all the correspondence in Java. But there's one more thing I want to talk about. Whenever you see any arrow that can arrange horizontally, it means something a little bit different, okay? That's something I want to talk about since you didn't, not every one of you study software design before this course, but it's a very basic concept, which will be easy to understand. So whenever you see green arrow, it represents, okay, let me just say, okay, something like this, right? With a solid arrowhead, like that, okay, something like that, okay, rather than empty. It's something called client-supplier relationship. Client-supplier relation. Basically, whenever you got any attribute declaration, you basically have some supplier, you also have some clients. But let's see exactly how to understand that. Let's say, for example, I have a class called students. Okay, over here. And you can think about every attribute declaration is going to represent a single client-supply relation. So of course, in a realistic projects, like in your projects, you may have hundreds of client-supplier. You don't necessarily have to include all the client-supplier relation in your ultimate design diagram. Choose the ones you think that you want to present. Okay? And by the way, so in your final report, we also require you to really present your design about your Java classes, right? Do you have to include all the 100 classes in your model package? No, you don't have to. You only choose the ones that are important for the TA and myself to understand your design. Right? So you want to be selective. Whenever you want to draw any design diagram, you definitely can be selective. It does not need to be 100% complete. Okay, let's go back to this example here. So let's say we have an attribute here. Let's say we have another class called card, let's say. Okay? And then every York University student has a YU card. Let's say YU card. And then something else. Okay? And we assume that there is another class called card, which I wouldn't draw right here. Okay? So this is the class where we are trying to use the service of another class called card. Right? Because once you declare YU card, you can say YU card dot deposit, YU card dot withdraw, etc. Let's say you got a meal plan, right, etc. We call this class where we declare these particular attributes the clients. This is the clients, which using some service. Symmetrically, the type of the attributes, which is called over here, we call that the supplier class. Supplier class, which providing some service. And you guys should be able to imagine right away, can a single class be client and supplier at the same time? Yes. For example, I'll just hand wave a little bit. Let's say, as far as this attribute declaration is concerned, card is the supplier, provide some service about the card. Maybe the card class itself declares some other attributes of type T. In this case, card itself will be the clients, and T here will be the supplier, right? So it's definitely possible, right? All right, so we got client, we got supplier, and in your design diagram, you don't really want to include a fragment of code like this. You don't want to. You want to visualize it. And the syntax, which you will see in many diagrams we're going to see today, is something like this. So we got the class called students over here. Okay, ellipse. So we got students over here, and we got another class over here called the card. Okay, and then the direction is going to be we go from the clients to the supplier. Okay, in this case, we go from the clients to the supplier. And then we also mention about the name of the attribute being declared. Okay, so to really complete it, we're going to say from students, which is the clients, go to the card class, that is the supplier, right? You can see there's a solid head here. And then we just put a name. So students, as a client, uses a card as their YU card. All right, I'll write it down as well. Students uses a card as their YU card. So you can definitely see the correspondence. Students, and card, and also YU card, and YU card. right? So that's a very nice way to kind of visualize about the important or relevant attribute declaration to present the design. Okay, we'll see many things like that in today. Okay. Another thing I want to show you very quickly is like this. So if you go to a lecture site, this will be a very nice way when you kind of prepare for the written test later, and also when you prepare for the exam. I'll show you how. You will see that under today's lecture, you can see there's a section there called design diagrams, right? So you will see we got composite, attempt number 1, 2, and 3, and also we got the 2 different versions of the composite, and also we got visitor, attempt number 1, and etc. Right? Well, so many design diagrams. Each one of them is going to somehow follow the notation I just mentioned. For example, you can click on, let's say, this one here. This one tells you a particular design for the recursive system. You can somehow take this one here and then try to comment on that about why it is good or why it is bad. So that would be a nice way to study for the exam specifically. That will be the kind of short answer or essay question I might ask you about in the final exam. Okay? So I'll leave the diagram to you. Of course, we're going to discuss each one of them today and also next Thursday, okay, in the makeup lecture. All right, so having known this about this notation, but since you guys only maybe see this for the very first time today, I'll keep reminding you. Hopefully, we can build some familiarity. Okay, attempt number 1. All right. So now, how do we read this diagram, first of all? To start with, remember what we are building here. We are building a recursive system like this, right? Cabinets, chassis, power supply, DVD room, etc. Right? That's a system we are building. And then let's now see the first design attempt right here. Okay? Let's say we got some clients who is going to use the equipments. The equipment itself is the system of the manufacturer system. And then we say it's an equipment here. So equipment, you can either put it here or here. It doesn't really matter. Okay? Whichever way you like. What we're doing is we say that equipment itself is an abstract class, meaning that there might be some methods in the class that's unimplemented. So if, for example, the price, we can somehow calculate what's the price for the equipment, which contains basic component and also subsystem, right? We're going to aggregate the price eventually. And then we got a mutator called add, which is going to take a single equipment. We want to add equipment into equipment, basically. And then ensure over here is a way to say what will be the post condition after calling the add. So this is so-called a post condition after the method's completion. Okay, we're saying that, for example, once we have added one single new components into the equipments, we're going to have that one there just at the end. Okay? Easy to see. And then we say that we got another client supply. This one is kind of interesting. It looks like a self loop. Whenever you see like a self loop as a client supply, that means you got a recursive type. Okay? Let me just say this one here tells you that it's a recursive type. And since we are seeing this for the very first time, let's take a look at the actual code, how we're going to declare that. Okay? So this one here is going to correspond to here. I'll put it here. So think about you got your class. I'll just say class for now. Okay? You got your class equipments. And then this one here tells you that you're going to declare a children attributes. And the children attributes of type list of equipment itself, right? So you actually got a list, which is a library class in Java. And then you say each element in the list is going to be equivalent, equipments. And then it's called children. What this say? Okay, first of all, you can see that the equipment is just the same as its resident class, right? And by the way, whenever you're using Java collection library, because every collection class in Java is generic. So if I want to say each element in the collection has a certain type, I got to instantiate a generic parameter. That's kind of the background you will have to check. All right? But I'm just showing you how to use it. Okay, so this part over here, correspond to this particular arrow. Okay, correspond to. Okay, of course, this is more like an implementation. This is more like a design. So if I only give you this, if you have any doubts, you can try to maybe write down the Java code very quickly if that helps. All right. All right, so we got equipments, and each equipment can contain, for example, several equipments. Let's say, for example, if you look at this diagram here, this is an equipment. Equipment here got an array of individual equipments right here. Okay? And then let's say a little bit more. Now we got some inheritance relationship. So now we are saying that what are the possible equipments? We got disk drive can be some equipments. Video card is equipment, so, right? This is extents. Inheritance. So this one here is extents. And we got some intermediate abstract class just to define some common parts, right? This kind of design you can also try to follow in your projects. So we say there's something called composite equipment. Think about composite as like a recursive, something can build recursively. So we say that cabinets, chassis, and also bus. So these are the three composite equipments. All right? So that's your design number one for recursive system. And now, for example, we might say we define chassis, video card, and disk drive. We can say once we have this composite equipment, which is of type chassis over here, we can say add some card to it, add some disk drive to it, right? Over here. That's an example use. Pause for 1 minute. Based on this design diagram, I can tell you this design here is flawed. It's not going to work. I can tell you the example I gave to you illustrate how it might work. What I didn't really specify here is something that can be written according to the design, but it wouldn't make any reality sense. That's something you guys will have to think about if I give you some arbitrary design in the exam. Of course, now in the class we'll practice together. Why don't you pause for 1 minute? What I want you to really pay attention to is look at the design itself based on the information you're given. I can tell you specifically for this one here. Pay attention to it. What kind of consequence from this kind of design is going to give you something that's not good? Yeah, think about it. I'll give you guys up to 1 minute. You guys can say anything. Even if that's wrong, that's okay. Why don't we start with you, please?
Every composite equipment is going to be counted as like cabinets wrongfully?
You mean the calculation for the price? Or?
Not necessarily, but like...
Yeah, say it again. Maybe I didn't quite catch you. Yeah.
Like cabinets, cases, and bus
yeah.
being like different equipments in the list.
Yes.
Instead of being a composite equipment.
Oh, that's okay, actually. You know, what you're talking about is, for example, I might see what you mean. So, for example, here, you might have, for example, cabinets, which is an equipment. And then I can say now I want to add maybe another cabinet, which is okay, like a smaller cabinet into a bigger cabinet, right? And then also in the same cabinet, I might put some chassis, and also I may put some bus. And then under this cabinet, maybe I'll put maybe chassis and maybe some power supply, something like that. That would be a valid use. May not be a very like a kind of configuration you will have for yourself, but at least it's a valid, right? The configuration. That's more like a hint. Think about what kind of way you can build some recursive system based on this design, but it's simply just wrong. Anybody? Before I tell you the answer. Once I tell you the answer, you will say, oh, yeah. Go ahead, yeah.
Can you say that creating a list from abstract class is wrong because you will be adding?
No, it's okay. So I see what you mean. So even though the list over here is declared in the abstract class, but it will be inherited to each of the concrete classes, so that's okay. At the runtime, you will just create a new dynamic type accordingly, so that's not an issue. Good try. Okay, you guys are pretty good. Just think about it, right? This kind of like a design thinking we want to have. Here's the issue. According to the design, the add method will be inherited to every subclass. Agree? These guys are good. Definitely, cabinet should be able to add some subsystem. Chassis must be able to add some subsystem because they're more like a components, right? Like a component collection. But how about these two? This design here allows something that's simply wrong, which I didn't say. For example, I might say disk drive over here dot add, and then video card. I'm trying to add some video card into the disk drive. Or the other way, I might say, maybe make it even more extreme. I can say I have maybe a video card dot add. So card over here is of type video card. And then I say add maybe disk drive. Can I add a disk drive into a video card? Of course I cannot, right? But this design allows that. This code over here, if you try to compile that, it will compile. So this is something allowed by the design. But does not make sense. All right, so that's the problem for design number 1. Are we okay with this? All right. In some way, this is more like a static type, kind of a reinforcement, because we know that this drive has a static type equipment if we declare that. So of course, it has the add available to it, right? Of course, you can call add on the disk drive, you can call add on video card as well. Right, let's do one more. How about we do one more attempt and then we'll take a short break, and then we got another 2 more, okay? One more. Okay, this one here, let's see what has been changed. The second one. Okay. The second one here, you can see now the children, what used to be in the equipments, children, we now move that to composite equipment. Right? That's a good improvement, all right? So you can see here, this one over here, children. So this is an attributes in composite equipments. So let's see the improvement first, okay? So now what I showed you earlier about adding a disk drive into video card, that ridiculous kind of addition, right? So now, would this be allowed anymore by this design? No, you wouldn't, right? Because now if you look at that, for the car over here, so the car has the static type video card. Does the video card has the add method defined? No, it doesn't, because you can see video card itself or its superclass does not have the add. It only exists right here. Okay, so it will not compile for the good reason. Okay, so not defined for children, attributes, and add. Okay, so this one here will not compile. Not compile. And this indeed is an improvement from design attempt number 1. This will be some improvement from design number 1. Okay. Are we good with this? Okay. That's an improvement, but we still suffer from some design principle violation. Okay? Why don't we take a short break by taking attendance, and then after the break, we can talk about that shortcoming. Okay? All right, so before the break, we spoke about the second design attempt over here where we got the children and also add that's defined in the composite equipment class over here, right? So that's a good improvement because now for anything that's ridiculous like adding a disk drive in the car, you wouldn't even compile. That's a good thing. But it still suffers from some design flaw, okay? I will get to it right away, okay? To do that, let me now try to give you some context over here, right? Let me just copy this one here. Okay. Here's one thing. Realistically, you may not have just a single tree in your projects. You may have multiple instances of the tree structure system, not a single one. So when you actually got multiple tree structure system in your projects, then this design attempt may suffer from something like a duplicates. Okay, I'll show you exactly what I meant. Okay. So let's say this. So let's say in the same projects, okay, I'll just say this will be maybe like a tree number 1, okay, and let me put another one here, and then I'll modify accordingly in just one moment. Oh, actually, let me make it just smaller. I'll zoom in when necessary, okay. Let's say in the same projects, let's say we have the same large project here. So that's your projects. And let's say we want to solve the problem about equipment, computer equipment. Let's say we want to solve another problem over here. Let's say it's more like a furniture, for example. Okay? Let's say we want to define a class called furniture. And then, for example, here, rather than composite equipment, we can say composite furniture. And of course, here, rather than cabinet, it could be maybe shelf, or maybe it could be drawer. You know, things like that. You see my idea. Okay. And also, maybe this will be a single chair, which is base case. And also maybe a simple desk, right? So this will be recursive system number 1. This will be recursive system number 2, right? So what's the design flaw really? The design flaw goes like this. For the composite equipment class and also for the composite furniture class, they actually share lots of code in common, meaning that you got lots of duplicates over there. Because what will you usually define in the composite equipment class or composite furniture would be something about adding an equipment, deleting some equipment, or maybe inserting some equipment somewhere in the middle, things like that. So these are very standard operations about adding something or removing something from the collection. And the way you do it here and the way you do it here should not be depending on what type of element you're storing, either equipment or furniture. You better actually put this definition here somewhere else in a single place. Okay, good. So let me write it down. So this one here, and also, oh, sorry, this one over here, and also this one over here. There was actually lots of code duplicates. Code duplicates. And whenever you got duplicate, we say that your code or your design smells. So the way to fix it is to really somehow move the common part into a single place. That's what we're going to do in design in the next attempt. Okay. To fix, move the common code to a single place. And single place could be a single class or maybe a single method. We'll see. Okay? But at least you want to understand what this flaw is. Okay? So for design attempt number 2, it's really about this part over here. It cannot be reused, really. Cannot be reused by another recursive system, like a furniture. By another composite system, such as furniture. Cannot be reused, so that's why we got duplicates, right? Design attempt number 2. Number 3. Design attempt number 3, we try to put this part here into a separate place. How about this? Let's say we want to put everything into an abstract class. An abstract class called composite. And it has generic parameter. And we're saying that this E over here may be instantiated into whatever element you want to. This may be instantiated into maybe equipments, or it may be instantiated into furniture. So you can think about when this is instantiated into equipments, it's going to correspond to this one here. When it is instantiated into furniture, it's going to correspond to this class over here. So that's the very definition for using generic parameter. All right? And I want you guys to pause for a moment and look at this design here. Right? So now you can see that we got the new bits, let me highlight, is really this new inheritance relationship with this new abstract class, storing anything to do with the collection operations. That's a new bit. However, this one here is still not ideal. Can anybody see how? This might test a little bit about your Java knowledge. A hint would be focus more not on the client supplier, like a green arrow anymore. Focus more on the inheritance arrows. Yeah?
Does it have similar problems like the first example where it's like we have that composite class that the abstract class has now that
Nope, not really. Yeah. The flaw that we have in the first design is already fixed by having the composite equipments right here. Okay, because we can now add, right? We can only do composite thing only for these, but not for these two. So that fix is still there.
But I guess what it means bus can't have children, right?
Bus may have children, yes. So bus is also composite by definition, right? Yeah. Mm-hmm. That's another one. Okay. We are not introducing any new problem. Okay. Okay. Interestingly, okay, I wouldn't blame you guys, okay? There may be something you didn't really see earlier, okay? It's more like a design kind of a scenario we'll talk about, okay? In Java, well, in order to do this, right? So that means you're actually going to have this class over here, composite equipments, extends equipments, and also extends composite. Let me write it down. That means you're going to have a class called, I'll say, composite equipments that extends, here, extends equipments. And also extends composite over here. Right? That's basically what the design is hinting. Can you actually do this though in Java? Can you extend multiple classes? No, you cannot. You can implement multiple interfaces, but you cannot extend more than one classes. All right? So this is maybe, I think that's good for your knowledge, so I'll dive a little bit deeper into this. Okay? First of all, this design is simply wrong because it wouldn't even compile. Right? Actually, even worse than design attempt number 1. At least design attempt number 1 can compile, but this one wouldn't even compile. Okay? So Java, well, I can tell you like a C# or other OOP language, they don't normally support so-called multiple inheritance. You cannot extend from multiple classes, but you can implement multiple interfaces. But I'll get there. So Java does not allow extending multiple classes. All right, I'll just explain very quickly about why you wouldn't allow that, right? This very famous design issue here is called the diamond problem. Okay, I'm not sure if you've heard of it, but it's a very straightforward problem to illustrate very quickly. Okay, so let's say if you allow multiple inheritance, you're gonna run into trouble in the following way. Okay, let's say we have a class called S right here. Okay, it's the super class that we want to have. Okay, we're a class called S right here. Okay. Let's say we got another two classes. Let's say we got class A over here, and then we got class B over here. So far we are fine, because so far we don't have any multiple inheritance, let's say, okay? And let's say in S over here, we got something abstract called do something, okay? And then in A and B, we implement do something. Okay, we got two versions, basically, okay? So you can think about here, I say do something. Also here, I also try to override or implement do something. Okay, I got two versions now. So far, it's okay. But here comes the issue. If I introduce another class over here, and then I want to use multiple inheritance. So again, we are trying to prove by contradiction. Let's say we allow multiple inheritance. What's going to happen is it's going to extend here and extend from another parents. Now we got issue, because both do something are going to be accumulated here. We don't know which one is going to be used. More specifically, let's say at a runtime, if we say S is a static type, obj is new dynamic type, let's say C. And then I simply say obj dot do something. Now we got a dilemma. Don't you agree? We don't really know which do something we should really call. Should we call it do something from here, or should we call it do something from here? If you don't have any other mechanism to resolve this clash, then you got confusion, you got ambiguity. So that's why multiple inheritance typically is not supported in languages like Java, C#, because they don't support any additional mechanism to actually resolve this. Okay, I'll just mention one more thing. Okay, so this is ambiguous. Ambiguous. Okay, so fix. A very valid fix would be, you want to somehow say, now as far as C is concerned, when I inherit do something into here, I can rename this method here to something else. I can say do something A. And then when I inherit here to here, I can say do something B. But the language itself must provide such a renaming mechanism. But Java doesn't have it, C# doesn't have it, so they wouldn't allow. Okay? Okay, to really resolve the name clash with additional syntax. Okay? For those of you who might be interested, for this part here, it's not covering the exam, okay? But so far it is, okay? So, for example, there is not really like a programming language per se, there's a design language called Eiffel. Like an Eiffel Tower, you know, in Paris, okay? There's a language called Eiffel there. They do have a way to really resolve the clashes for when you actually got this kind of typical diamond problem here, okay? So that's why they would allow multiple inheritance. And multiple inheritance, arguably, is more at the design level. But for implementation, we can get around by having maybe interfaces. So that's why in the ultimate design for composite, you will see a mix of abstract class and also interface. All right. All right, anyway, so I think it's just made the kind of the discussion more complete for your knowledge. So you're thinking about this one like a version 1 and this one like a version 2, right? Without any further renaming, you just don't have a clue about which one should be called. All right, having this in mind, let's now take a look at the final design, right? But so far we talked about 3 different designs along the way. Each one of them has its own limitation. So when you study for the written test and for the exam, you should really know how exactly. Okay, let's now talk about the final composite, and we'll look at some Java code. Okay, so this will be the final composite design pattern. We're going to go over them quickly, but you can look at that right here, composite. Okay, you can also download this diagram if you want to. Okay, that's the one. It's also there on the lecture site. Okay, this client-supplier relation is just the same as before, and also we only got the price, which is going to be aggregated among all the components, the recursive and the base components. And then you can pay attention to this one is very critical because the children and also the at, etc., they are here, the equipments, right? That's the recursive equipments. Okay, so this is a recursive type because they simply refer to the equipments. That's number 1. Number 2, you can see that we got a class called composite over here. Composite over here. And then we actually got the children over here also. And also here we got the add method here. Okay, you can look at maybe the design a little bit more in more detail, after the class. And you can see that we still have these 2 arrows over here. However, they are really not exactly multiple inheritance. This one here, yes, it's an abstract class. So this one will be extends. And this one here is going to be increments. Okay, you can see this class over here, composite equipments, implements the equipments interface, and it extends the composite abstract class. All right. The reason that this one has to be abstract class is because we want to have some code to be reused among furniture, equipment, etc. It cannot be an interface. For interface, you cannot have any code implementation there. All right. So guys, please, after the class, take a look at this design here and see how individual components should work together. And let me show you some Java code. Okay. Let's see how exactly it's going to work. Okay. Oh, one more thing. You can see why the composite over here is a generic class, right? You can see this one here. Composite here is generic class, the E here. So to answer that question there, the generic parameter E here can be instantiated by different types. Okay, sorry. By different types for code reuse. Okay, I'll show you exactly how. Okay, I believe I have something here, right? So that's really the final ultimate instantiation. So you can see here we got the composite right here. So here, when we go for this one here, the composite equipments, you can see that one there we say extends composite, and we got equipments, which correspond to the equipments over here. On the other, so that one also extends, right? On the other hand, with the same class, you can see we extends composite of furniture, which correspond to the furniture over here. And that one there, of course, extend the same class. So we're basically having different instantiation for the recursive system, right? We have different. On the other hand, we actually can reuse all the code we define generically for the add, delete, etc. to do with the collection, right? It's a really nice way to really factor out the common part that's going to be reused by different recursive system, right? So try to take a look at all these design that are all nice stuff that you can actually incorporate into your maybe project if practicable. Okay. Any questions? We're good? Okay. So let's now go over the Java code very quickly over here. So this will be the final Java code. So you will see equipments over here. Each one of them has a name, has a price. And here I said uniform access in the following sense. The price over here, okay, it could be the price for some base components, or it could be the price for some composite components. So these two both have the price method they have to implement, but they will implement them differently. For example, let's say for video card. And then for the price, give me one moment. Oh, there we go. So video card is simply a base component, like a base equipment. If you look at the base equipment here, that's right here. And that one there has an attribute price. And the price method is simply implemented by returning the price. So very simple implementation for the base component, right? That's how you trace back to the code. That's one scenario. What about another scenario? So price may be implemented using a green root if that's base. On the other hand, we may implement it using another orange root, let's say for the base, for the composite. How do we see that? Okay. For example, you might see chassis over here. That one there is a composite equipment, right? So when we go to the composite equipment over here, and then you will see for the price, now it's much more complicated to use to really implement the price for some composite equipment. Somehow you will need to use a loop right here. Okay, you want to use a loop, and then you want to say for every child elements in the equipment, we want to recursively figure out their price. Okay, let me refer you very quickly to the diagram from before. Okay, just give me one moment. Right here. Okay, let's say for example, if I say cabinet over here dot price, in order for me to figure that out, cabinet is not base. It's not recursive case. I need to run a loop for 3 iterations. Iteration number 1, I'm going to say child number 1 dot price, which will involve another 2 iterations. And these 2 iterations, iteration number 1 is going to figure out the price for the card, which is just the attributes. And also the second iteration is going to figure out the price for the hard drive, which is just attribute access. And when we go to the second iteration for this one here, it's going to involve further another 2 iterations, which will compute the price for this and also for this. That's kind of the high level tracing, but I think I should really trace one together with you just to see. This will be actually very valuable because when you actually do the projects for your particular system, you might find the need to actually debug, using a breakpoint debugger in Eclipse. This might be useful. Why don't we do that very quickly? Okay, just see one example. I'll just give you enough information so you can actually take a look yourself too. Let's say we have a JUnit test. Okay, we got equipment, we got bus, we got cabinet, we got chassis. Okay, and this is kind of the object diagram that we want to build at the runtime. Okay, let's see. Okay, so give me one moment. I'll just make sure I got it consistent in my notes over here. Good. Okay. Let's say we got all these objects created. So we got cabinets, we got chassis, we got bus, we got drive, we got car, right? All good. Let's now talk about each individual line of building the tree. Okay. So let's say we got bus.add card. So bus over here, add card. So child number 1 at index 0 should point into the card. And also we got chassis, bus, and drive. So chassis is over here. So we got bus first and then drive. So bus should be the first child, and drive should be the second child. Right? That's how we build so far. We're going to build bottom up. And finally, we got cabinets. And the cabinet is have only one child. It's going to be chassis. So far here, we're just building the tree. Building the tree. And the ultimate line we want to trace will be cabinet.price right here. This will be the final one we want to actually trace, right? Cabinet is referring to an object of dynamic type cabinets. So when we say the price, which version of price are we going to call? It's going to call the composite equipment's version, not the base component version. So we're going to go into this price over here and follow the loop, right? Eventually, we are going to reach maybe the disk drive and also video card. So these two, when we say drive.price and card.price, dynamic type over here is disk drive and video card. They are base equipments rather than composite equipments. In that way, we're going to call this price over here as opposed to the price over here, right? So these are the little details you want to watch out for. All right. Okay, good. Okay, let me see this. Okay, so I only got about 5 minutes, so this is what I would do. I think for as far as your programming test is concerned, even though we haven't really got a chance to cover the rationale or the more design rationale or design theory about visitor pattern, but for your programming test, I think just make sure you're proficient about manipulating the object classes the way we do in the tutorial video. It should be okay for next Thursday. But for next Thursday, I'm just gonna start from this example here. I'll do some quick tracing about how this can be understood. And then after that, I will also talk about the visitor pattern. Hopefully we can finish that next Thursday night. For your programming test, I'm gonna give you the guide and also the practice test by the end of tomorrow. You guys can definitely practice simulating it over the remote lab following the instruction. Next Monday, if you can make it to campus 102, Lassam Building, and then 5 p.m. Me and the TA will be there. And then if you got any follow-up question, you can definitely ask during the mock-up test session. And on Thursday, we have the real test. Okay? Thank you. We'll finish a little bit earlier today.